Hi. In last class, we have completed the packing efficiency in case of BCC, right? So we left with one concept, that is packing efficiency in FCC, right? So already we have calculated the packing efficiency of BCC as well as simple unit cell. So now we left with only one concept, that is packing efficiency of FCC. So again, this question will be of 3 marks. So among these three, simple, BCC as well as FCC, one question will be very compulsory for your main examination. So that's why please go through thoroughly, right, for these three questions. Why? Because in this chapter, these three are very, very important, I can say, right? So first of all, again, to solve these type of questions, what we need to do is, for FCC, we need to draw a proper diagram, right? So see here, so FCC is nothing but, again, I want to remind you that FCC is nothing but it is a type of unit cell in which the constituent particles are not only present at the corner, but they are also present exactly at the center of a face, right? I mean at the wall. So first we can show the constituent particle at the corner as well as at the faces. How many faces? There are 6 faces. So front and back, like this. 3D one we cannot see on the board. So thus we can say one wall is front wall and other one will be the back face, right? So there are 6 faces. So this FCC is very simple, like simple unit cell. BCC is a little bit trickier. Why? Because there one we can see the two triangles. So here it is very easy. So FCC is nothing but, see, we can take or else directly one we can see by taking one face, we can calculate what is the packing efficiency in case of FCC. That means how much it is packed or how much it is empty. So let us consider any face, right? So consider this face. This face means what I need to do. There is a center atom, so that's why one we cannot forget this center atom. So we have to take this, right, line. I mean, you draw first a imaginary line and then you can consider these things. If you consider only one face, then definitely all 6 faces will come. So now see, one constituent particle for this, and there is one more, and then this, not this, right? Very important. If you understood, then okay. Otherwise, what you can do for this FCC is you can take just only one face. I mean, this face, if I remove separately or if I draw separately, then the one face looks like this, right? So I just took this face separately. So that means, see, faces means corner as well as at the center of the face. So thus, so this is the imaginary diagram, right? So now one atom, one more constituent particle, and this one. So now you can draw a imaginary line diagram, right? So imaginary line. Now you can name this. I mean, you see here, for angle we will do like this, right? So that means it will be very easy for you. You can understand very easily. So like you take like this, no problem. You can take like that also, no problem. But for better understanding, one we can consider this type of diagram. So now, so this is the exactly imaginary part of this. You need to draw this. Don't forget, right? After that, you can show one face, right? So now you can name A, B, and C. And now see, A and B is nothing but corners. Corners are nothing but the complete distance between any two corner item can be represented with edge length A. And what is B to C? Again edge length. So there is a. Now a half of the distance, radius, right? So half of the distance from here to here for this atom, there is a r. And now for this middle, there may 2r may come. Why? Because half of the distance, right? R and r. And now for this, from here to here, there is a 1 more, right? So this is the complete diagram of what FCC type of unit cell. So what I did, I just took one face outside for your better understanding, and now what I did, I just mentioned their particular names. So now after doing this, directly one we can move towards its definition. So for solving this, so first part will be FCC means, directly in shortcut way I will write FCC is nothing but the constituent particles are present at corner as well as at faces. That's it. So now the next point will be the number of particles, I mean atoms present in the number of atoms in FCC is equal to how much? 4. Already we have calculated during last classes, right? So in number of atoms present in the FCC is nothing but 4. So now after having these things, one we can directly move towards the angle, right? So I have not explained till now about angle. So in case of FCC, the one angle will be created. That is what you can easily imagine that there is a one triangle, that is ABC. So triangle what? ABC. So triangle ABC. Triangle ABC. So ABC means, according to Pythagoras, AC square is equal to AB square plus BC square. BC square. Shall I have this? I will have this. So you need to draw these two. I mean, if you are understood in this diagram only, then there is no need to draw this, right? So now what is A to C? A to C, 1, 2, 3, 4, 4 r whole square. Okay. What is AB? That means there is a its length A square plus what is BC? BC means again A square. So 16 r square, 4 4 is 16 r square as it is. A square, I can say 2A square. What we need? We need r. So put this r outside. So now 2A square as it is, there is a into in between, so thus this 16 will come directly in at the denominator. So it will get cancelled, so better you can cancel it. 2 1 2 1 into 8. So now we require what? R. So that means 2 is gone, so thus square and root will get cancelled, divided by what? Root 8. Or else you can take root 8 value also, or directly you can put root 8. So this is what our value for FCC, right? I repeat. So there is only one angle will be created in case of FCC type of unit cell. What is that? That is triangle ABC. So in triangle ABC, according to Pythagoras, AC square is equal to AB square plus BC square. So already we have the value for all the things, that for AB as well as for BC as well as for AC. So AC, A to C, what are they? 4 R. So that's why what I did, 4 R. There is a AC square, so that's why whole square, which is equal to AB means there is a edge length. So that's why A square plus BC is nothing but again A square. So now 4 4 is 16, 16 R square This is equal to a plus a to a square as it is. So what we require radius of this. So thus I have to this r square outside. R square is equal to 2a square divided by 16. Here we can go for dividing this by, because it can get cancelled. So 2 ones are and 2 8s are, right? So thus 8. So root, if you want, you can write root value for this root 8, right? So this we require now for our packing efficiency formula. So right now directly you can put this value of r in what, in your packing efficiency formula. So thus packing efficiency is equal to number of atoms. So I am writing every time. Why? Because this is very important. Most of the student forget this. So that's why every time I am writing this formula, whole divided by a cube into 100. So now number of atoms, we are in, don't forget, we are in FCC type of unit cell. So how many number of atoms are present in the FCC? 4 into 4 by 3. Pi value we can put 3.14 into r cube. What is r? A divided by root 8 whole cube, whole divided by a cube. We put like this. So here when we can again go for a cube can cancel. So now our equation is very simple now. So now 4 into 4 by 3 into 3.14 into 1 by root 8, right? Root 8, what is there on that cube? So we put that cube as it is. So now what you need to do is you take first root 8 value, then you divide that value with 1. So whatever the value will come, you cube it. I mean, you can multiply that for 3 times and then multiply with this values. Then definitely approximately we will get 74% packed and rest 26% is empty in case of what? In case of FCC unit cell, right? So this is all about, these are very easy. So try these in your home by yourself. So thus one you can come to know what are the difficulties you are having while solving these type of packing efficiency. So until and unless if you won't do by yourself, definitely you won't come with any doubt, right? So that's what I thought. That's why I request you to read yourself. I mean, practice these by yourself. Definitely doubt will come, right? Then you can check those points wherever you are going maybe missing the points. Those points you can consider and you can ask the doubts, right? So after solving all these, I want to explain you one thing that is very important for your competitive examinations, right? See here in simple, right, approximately 58% is packed, and in BCC how much? I mean 54, I think, sorry, 54, and in BCC we have approximately 68, and in FCC 74% it is packed. So what does it mean? So what is the indication? So from moving from simple to FCC via BCC, what is happening? Our packing efficiency is increasing. So what does it mean? If it increases means what happens? That is the point. This type of question you might see in your competitive examinations. For that, I'm just taking 2 minutes of you. So if the packing efficiency increases, then this increases. That means the stability increases. Stability means stable state, or else very strong state one we can say. Very strong state one we can say. Stability, that means see here Here the empty space is more as compared to BCC, and in BCC empty space is more as compared to FCC. As the empty space decreases or the packing efficiency increases, the stability also increases. Why? Because as the number of atoms are more in the unit cell, then definitely during first or second class, what I said, some of the things are very easily one we can remove, but some of the solids will require a more amount of energy. That is the reason wherever there is a FCC type of packing efficiency in solid, there we feel more, I mean, we put some more amount of energy to break the solid chemicals if they have FCC tag. If they have simple means, one we can very easily remove, right? Now you can clearly observe that some of the solids very easily they undergo into the break, but some of the solid will not. Why? Because this is the reason one we can say, right? So wherever there is a more packing in a unit, then definitely that solid will be very strong. So these things you can keep in your mind. So these type will not be asked in your theory. So these are very important for your competitive examination, right? So this is all about your packing efficiency. During next session, definitely we will go or we will move towards the density problems, right? Thank you.